All right, Miss Christina. I know you said you had a question. Did you want to go and knock that out before we get into
Well,
chapter
it
14?
was like on like the one of the beginning chapters. I was trying to do the 9.5, like
Mhm.
the last two questions. They was problem solving, and it had a fraction. Like
Mhm.
they gave us, what was the problem they gave us? T equal 50 plus n minus 40 over 4, and they gave us the number 98 to plug in for n.
Okay.
Yeah, and I could not figure out, like, I don't know, I couldn't figure out how to do it.
So you said plug in 98 for n, like that?
Uh-huh.
All right. So go ahead and do the subtraction right here first.
I got 48,
Uh,
48, I mean 58.
58. Okay. Uh-huh.
Okay, and then I did that part,
Mhm.
and I couldn't figure out what to do next.
Okay. So now you could reduce this if you wanted. It can't go four doesn't go into 58 all the way,
Right.
but you can reduce it by two if you want.
But 2 don't go into 5.
You're going to 58.
Oh, okay, so
Yeah.
we can go with 24.
29, because that'd be 18. Yep. Be 29.
29. I said
Hmm
24.
So 29 over 2.
Oh, so okay. So all right. Let me see. So I should have put 50 over 1 and simplify before I even started, because I
Yeah.
okay.
That's if you wanted to do. Now you didn't necessarily have to
Okay.
simplify, but
So
that's if you wanted to deal with a smaller number.
well,
Smaller
I don't
numbers.
know which way would have been the best way, because I'm not for sure which way to do it. So
Because
maybe,
well, I say it like this: either you simplify right here, or you gonna have to simplify at the end. Either way, you're gonna have to simplify at some point. So it doesn't matter.
okay.
hmm So, but you do need to add these fractions, and so you need a common denominator. So you multiply on top and bottom by 2.
So put the difference. Oh, when you simplify over 2.
It should be 129 over 2.
Where'd you get the 100 from?
Uh,
Oh,
you
yeah.
had to, yeah, you had to multiply top
550
and bottom.
times 2 plus 29. Okay.
Mm-hmm.
And the denominator is 2. So there's 1 times 2 is 2 all the way across.
Mm-hmm.
So, oh, why? Oh, never mind. So why you can't, once you added it to, I thought you said it was 129. Oh, so that's just the way you wrote it down. That's just the way you wrote. I'm like, well, where'd that come from? I got it.
All right, cool.
I'm like, where did 129 come from? But you had already added. I wasn't paying attention.
Mm-hmm. Yeah, it's all good. All
So
right.
that would be the answer.
Mm-hmm.
Okay, I'm gonna try it.
All right. Sounds good.
Thank you.
Yep.
I got my example written down already. So thanks.
Okay, cool.
Okay.
All right. So just let me know.
All right.
Mhm. All right. So 14.1, simplifying rational expressions. Um, and I don't know if y'all noticed, man, we only have like a month left.
That's
And
why I'm
that
trying to catch up.
and that's it, man. So we on severe countdown mode. Um, so
Severe
simplifying rational.
behind mode.
Yep. So, but we still got time though. Still got a whole month to take advantage of the time. So we'll be all right. So we got simplifying rational expressions. Rational expressions are basically fractions. But most of the time when you have a variable in your denominator, that's when most of the time that rational expression term comes up. So these are just examples of rational expressions. You know. All right, 5 over x plus 7, x plus 3 over x minus 5, and so on. These are examples of rational expressions. All right, scrolling up. So this first exercise says determine the function values if possible. They give us m of x is equal to x plus 3 over x minus 5. And what they would have done here is, let me erase this. They would have given us m of 2, which basically means you're going to take 2 and plug it in wherever you see x. And so that's what I did right here. Plug in 2 where I saw x, so that's 2 plus 3 over 2 minus 5. 2 plus 3 is 5. 2 minus 5 is negative 3. So this is negative 5 over 3.
Why are you plugging in the 2?
Because they told us to. Right here. That's it. Right here.
Oh, okay. All
Yeah.
right.
Yeah, that's what, yeah. So say again.
I thought we were just randomly adding that 2.
Oh, nah. And yeah, that's why when I erased it, that's why I said what you would have gotten is just that. So that right there mathematically is enough information to tell you what to do. So they telling you, that's function notation. So when you see that, that means plug 2 in wherever you see x. Because there was an x there, but now they put a 2 right there. So that means you plug in 2 wherever you see x.
I have a question.
Uh-huh.
For the reciprocal, this would it be wrong if we didn't put this and flip it? If we didn't flip the fraction over, you see where you have 5 over 3 and then 5 over 3 and then negative 5 over 3.
Okay. So now remember the reciprocal. The reciprocal of 5 over 3 is 3 over 5. So that's not necessarily, that's not really the reciprocal. All you did was bring the negative sign up to the top.
Oh.
So that's proper notation. Normally you don't normally you don't leave the negative sign in your denominator.
So okay, so you always bring it up. All right.
Mm-hmm.
Okay, so let me make a note of that.
Yep. So 5 over negative 3, the best way of writing it is either negative 5 over 3 or negative without front. Either bring it up top or put it out front, but normally they don't leave it in your denominator.
Okay, so if we were to do it like the negative in front, it wouldn't be marked wrong.
Nope.
But if we were to leave the negative in the denominator, they would mark it wrong.
You have to try it in my math lab. I wouldn't mark it wrong, but it depends on how my math lab is programmed.
Okay.
Yeah. So. Yeah.
Yeah. The math lab thing is weird because when I was doing the graphs, I graph it, but you can't, it don't let you graph like 5/3 and stuff like that. It wants you to be on a solid line, like 2 or 3, and I'll be getting that messed up.
Yep. So you're gonna have to be strategic with your points. Now, this is not graphing, so we're okay with this. But yeah, when it comes to graphing, they do want you to lean more towards, solid numbers versus fractions. Yeah. All right, so let's do another one. So remember in the directions, it said determine the function value if possible.
Wait a minute.
Hmm?
I didn't write this other.
So in this next one, you would have just gotten m of 5.
Okay.
So you plug the 5 into the equation, and you would have gotten 0 in your denominator. And 0 in your denominator is undefined. So that's what it meant by if possible.
So when we see this, this is undefined. So would this be the answer, or would we just put 8?
Nope, undefined.
Oh, so undefined would be the answer. Okay.
Right, because remember, 8 is actually 8 over 1 as a fraction.
Okay, yep. So, all right.
And let me mention this too. You didn't say it, but 0 over 8 is 0.
Right, okay.
So 8 over 0 is undefined.
What does that say? Cannot have a
0.
What's that?
0 in denominator.
In denominator. Okay.
Mm-hmm. Excuse me.
I don't know what you're yawning for. You got a long day ahead.
You're right.
Okay.
All right. All right. So now this next one, you notice the directions on A. It says write the domain. They ask us in set builder notation. Let me see if this book actually asks that for you. But we're going to write the domain. Where's my book? Where's my book? And when we look at trying to find the domain, we want to look at the values that we cannot use. Because remember, we just finished talking about not having 0 in the denominator. So any value that will give us 0 in the denominator is a value that we cannot use. So we would take that denominator, set it equal to 0 and solve. So we have v plus 7 in our denominator. We want to know when is our denominator equal to 0. So that's why we set it equal to 0 and then solve it. And we notice that we get v is equal to negative 7. That negative 7 is the value that we cannot use. We cannot use that value because it would give us 0 in our denominator.
Can you say that one more time?
The value that we cannot use is negative 7 because when you plug it in, you'll get 0 in your denominator.
Oh, okay, right here. All right. Negative 7. Okay.
So it says right set builder notation. They mentioned it in here, so we'll just keep rolling with it. So notice how you started off, set builder notation. The variable that we're using is v. So I have v, this long line, and then I describe what my solution is. And it's all values, all real numbers, and v is not equal to negative 7. So remember, we got that from right here. So that's how you would write the domain in set builder notation. So it says v is all real numbers, and v is not equal to negative 7.
V is all real numbers. I don't think I understand that part. What is in front of this right here?
This right here,
Yeah.
that's symbolism.
Oh.
Yep, just your symbolism. That's set builder notation. That's how they want you to write it. If they ever ask for set builder notation, that's
So
how
I'm not understanding what that. Oh, so that's just the beginning of the parentheses. So the V with the slash, a V slash V. Is that what that's supposed to be?
Mm-hmm. So
Okay.
this is pretty much okay. So this part right here is establishing what variable you're using. We know we're using v,
Mm-hmm.
and then this other part is the description of the domain, the values that you can use for v. So we can use all real numbers. We can use any number except this negative 7 right here. So that's basically what you're saying. You use
How we know that? How do you know that?
because we just did it right here. Remember we said equal to 0 and solve. That's the only value that will give you 0 in your denominator. So that's the only value that you cannot use. So remember, we just saw that we plugged in 5 right here, and it gave us 0 in our denominator.
Right.
Nothing else will give us 0 in our denominator but that 5, because 5 minus 5 gives you 0. So that means I can use everything else. So the same thing is here.
I don't understand that because 7 minus 0, 7 is it's always 0. You can't. You understand what I'm saying? Is it anything divided by itself 0?
Wait, hold on. You're doing different operations. You got different things going on. So
Yeah.
7 divided by 7 is 1.
And then when it's but 7 divided by 0 is 0.
Yeah,
or
but
any number.
7 divided by 0 is undefined.
Oh, so the answer wouldn't even be 0. The answer would be undefined.
Right. That's what we were saying here.
Okay.
Mm-hmm.
All right.
Whenever you have 0 in your denominator, it's undefined. So that means you cannot use anything that produces 0 in your denominator. So this negative 7 right here, when I plug it in right here, will give me 0 in my denominator. Right? Because negative 7 plus 7 is 0.
Yeah.
So that would give me 0 in my denominator, which would be undefined. So I cannot use -7.
Okay, got it. All right. I was really confused for some reason.
Yeah, that's fine.
I think I still am, but I'm gonna keep going.
So just go. This is the process. You set your denominator equal to 0 and solve. And that's what we did right here. That's how we got -7. That lets you know that's the value. That's why I wrote right here. That's the value that you cannot use. And so that's what we did right here. V cannot be equal to -7.
A V cannot be equal to -7 because.
That gives you 0 in your denominator.
Okay. All right.
All right.
I'm moving right along, but try to put. I told you I had to let it sink in for a minute. I'm just not getting it yet.
That's all right. And the more times you do it, and once you get into the homework, that might be when it click all the way as well. And so then here, your domain in interval notation. We've dealt with interval notation before. So you can use every value except for -7, and that's what this states right here. So I can go from -infinity up to -7. Then I can go from -7 to infinity. Don't forget parentheses mean I can use everything up to that value, but I cannot use that value. So that's why we use parentheses on the -7. So I can get as close to -7 as I want. I just cannot use -7. All right. So those are two different ways that you can represent your solution set, whether it be set builder notation or interval notation, or represent your domain, not solution set, domain. I'm sorry.
Yeah, this one was on my test also. I'm like, I was lost. I was like, I never touched on this one.
You talking about domain?
Yes, on the second test.
Okay, I'll take a look at it. Because I know we dealt with interval notation. They shouldn't have been asked about domain, but you probably were asking about your interval notation. So remember when we
Yeah.
saw when we had x is greater than 5, that's when you would
Mhm.
use interval notation. So that's probably how you when you saw that. Yeah, stuff like that.
Yeah, I'm lost in the sauce with this one.
All right. Well, let's look at the next one. Let's see if that'll help. All right.
I ain't by myself.
Oh no, well you should never feel. I keep telling people when you're in a math class, you never feel like you're on an island, because there's always somebody that's questioning the same things, whether they say it or not. All right. So the next one, we want to go through the same process. We're talking about writing the domain. So we have a plus 8 over a squared plus 5a minus 36. And the first thing you want to do is set the denominator equal to 0. And so that's what we did here. We want to figure out what values cannot be used as far as plugging in values for a. So we set our denominator equal to 0. We want to know when is our denominator equal to 0. So that's why you set it equal to 0. So a squared plus 5a minus 36. You will factor that out to a plus 9, a minus 4. Set each part equal to 0, and that'll give you a equal to -9 and a equal to 4 once you finish solving. And so in the purple, what you were saying is you want to figure out what are the restrictions on a. What values can you not use? All right. Questions on that before we go to writing out our domain?
2 seconds, please.
Mm-hmm.
Um, okay, I'm caught up now. I'm ready.
All right. So not interval notation, set builder notation. Notice how we started the same way like we did with the V. It's A with a long bar, then A is all real numbers. And this time we had two values that it could not be equal to, that -9 and 4. And then for your interval notation, you will use everything except for the -9 or the 4. So that creates three different pieces to your domain. -infinity to -9, -9 to 4, and then 4 to infinity.
Wait a minute.
Questions?
Can you scroll up? I'm missing this little purple box. Well, can you show me what that box is?
It says, what are the restrictions on A? And that's what we were finding out. What values can we not use when it comes to plugging in for A? So we can use everything else except for the -9 and the 4. All right. Very good. All right. So the next thing we want to do is simplify your rational expressions. So what we would have had is this: x squared plus 14x plus 45 over x squared plus 2x minus 63. And they ask us to simplify it as much as possible. So what we're going to do here is factor the numerator as much as possible, factor the denominator as much as possible. And then we're going to cancel out the quantities or terms that they have in common. So if you look at the numerator, it factors out to x plus 9, x plus 5, x plus 9. Denominator, x plus 9, x minus 7. And once again, you see that this is dependent upon your factoring capabilities. So if you need help with factoring, make sure you email me so we can set aside a talk, outside of class. Make sure you're straight with factoring, but it's going to take some practice, to get your factoring skills straight. So after that, you see that we have x plus 9 that's in common with the top and bottom. So we cancel out that, and that'll leave us with x plus 5 over x minus 7. All right, questions on what we did there? All right, so the next one, 3p minus 15 over 3p squared minus 75. Once again, directions would just be simplify completely. So I factored out a 3 from each term in the numerator, and I was able to factor out a 3 from each term in your denominator. So that'll be 3 times 5 minus p, 3 times p squared. I said 5 minus p. 3 times p minus 5, excuse me, and 3 times p squared minus 25. Then we recognize that this is a difference of squares. So that actually factors out to p plus 5, p minus 5. All right. So now we cancel out what's in common. You have a 3 that's in common with the top and bottom. P minus 5 that's in common with the top and bottom. So notice the whole numerator cancels out. Don't forget, when everything cancels, you're supposed to leave a 1 there. So that factorization or that simplification would be 1 over p plus 5. Or that expression in its simplest form would be 1 over p plus 5. All right, questions.
I can't really ask you right now.
Mm-hmm. All right. Is this in the chat? Yep, that's not a problem. All right. So let me erase this. So here we have p plus 1 times p minus 2 cubed and p plus 1 squared over p minus 2. So if we were to write each one of these out, let me erase this. We see that we have p plus 1 once, but then you have p minus 2 3 times because that's p minus 2 cubed. Then on bottom, we have 2 p plus 1s and just 1 p minus 2. So you don't have to always write this out. I'm just doing it just for the visual purpose of it. Just make sure we understand what cancels out and what doesn't. So one of the p plus 1s cancel. Then we have, is it 2 of them? Nope, just 1 p minus 2 cancel. So you know you're left with 2 p minus 2s on top and just 1 p plus 1 down bottom. So that's how we wrote that answer. Remember, all of this is leaning on, your fractions. If I have 4 over 6, and I want to reduce that, that's 2 over 2. 2 times 2, that's 2 times 3. And I cancel out those 2's that are in common. And that leaves me with 2 over 3. So it's the same thought process, the same premise of canceling out the same thing that's in the top and bottom. All right. Questions before we go to the next one? All right, so this one we have 8y plus 8 over 2y squared minus 6y minus 8. All right, so I always mention you want to take the GCF out first. And so that's what I did here. I factored out 8 from the numerator. That left me with y plus 1 in the parentheses. Then I factored out 2 in the denominator. And that left me with y squared minus 3y minus 4 in the parentheses. Now we want to factor this trinomial. And that's what we have. It gives us 8 times y plus 1 over 2 times y plus 1 minus times y minus 4, excuse me. All right, and then we cancel out what's in common with the top and bottom. Y plus 1 cancels. And then we see that 2 can divide into 8 and leave you with 4. So what you're left with in the numerator is just the 4. And then y minus 4 in your denominator. All right. Questions. Make sure we're good. All right. So the premise of 7.1 is that you're factoring the numerator out completely, factoring the denominator out completely. Then you're going to cancel out what's in common with the top and the bottom. All right. So now 7.2 does the exact same thing, except it adds multiplication and division. So it pretty much adds one more step to the process. So erase this. So what do I mean by that? So if I have 2/3 times 9/4, right? If I were to factor out each numerator and denominator, but a 2 and a 3 can't factor out any. But I can break down the 9 into 3 times 3 and the 4 into 2 times 2. So that's what I did right here. Now, when it comes to multiplication, whatever's common with the top and bottom, all of this is in your numerator. All this is in your denominator. So anything that's in your numerator can cancel out. Anything that's in your denominator can cancel. So I can cancel out one of these 2's, and I can cancel out one of these 3's. And you're left with 3 over 2. All right, so let's try it again. Let's do this. So let's try using variables. We have 5r squared s to the 4th over 28r s cubed times 14r squared over 20s squared. So just like we did here, we're going to factor this out as much as possible. So I'm going to remove all this stuff. All right, so I took the 5. I didn't do anything with the 5, but I broke down to 28. 28 is 4 times 7. And I broke down the 4 into 2 times 2. 14 is 7 times 2. And then 20 is 4 times 5, but then broke down to 4 into 2 times 2. So all I did was I broke down each number to its prime factorization, so that we can clearly see what's in common with the top and bottom. All right, let's see what my color coding. Yeah, I won't mess with it. All right, so there's only one 2 that we can cancel out. So it doesn't matter which 2 in this denominator that I use. Just remember you only can cancel it out once. So 1, 2 cancels. I have a 7 that will cancel. Then also a 4 that will cancel. I mean, 5 that will cancel. All right, so all of my numbers cancel out in the numerator, and that leaves me with, I don't want that. Two times 2 in your denominator. So that's 8. So I have r squared times r squared. That gives me r to the 4th. And then s to the 4th, still there. And then on bottom, 2 times 2 times 2 is 8. And I have r. And then r cubed times r squared is r to the 5th. So you're going to have to be careful with what you have left, careful with your terms, and be organized.
Yeah,
But you know,
get lost.
yeah, but it's all here if you take your time. So in other words, still have my eraser on. So in other words, take your time. R squared, give you r to the 4th. S to the 4th is still here. You know, it's just that you just have to go piece by piece and be careful with your numbers and signs. So now we still can reduce this because we have r to the 4th over r, and we have s to the 4th over s to the 5th. So don't forget, when you're dividing your fractions, dividing your terms, you're going to subtract your exponents. So that's 4 minus 1 for r, 4 minus 5 for s. So that's r cubed, s to the 1st power. And then don't forget, if you have a negative exponent, you bring it down to your denominator. And so this would be your most simplified way of expressing that answer. All right, questions before we look at another one? All right. So next one, we have 3w plus 21 over 16w to the 6 times 64w to the 6 over 9w plus 63. So let me erase this.
What is that over a W? That W?
Let me see. Are you talking about right here?
Yeah, what's that?
6.
Oh, it's 6. Okay.
Mm-hmm. 6 for your exponent.
All right then.
All right, so first numerator, I factored out 3. So that's why we have 3 times w plus 7. This denominator I left the same because of what happens in my next numerator. Right here, I pulled out 4 because 4 times 16 is 64. But you notice that 16w to the 6 is the same thing right here. Then looking at this 9, looking at this, I factored out 9. So I have 9 times w plus 7. And also, you recognize that 9 is 3 times 3. So when it comes to canceling out, I can cancel out one of the 3's that's in the 9. Then I can cancel out w plus 7. Then I can cancel out 16w to the 6. So what I'm left with in my numerator is 4, and in my denominator, one of those 3's from the 9. So that's how we have 4 over 3. All right. Questions before we look at another one? All right. Same type of deal. We want to factor the numerator and denominator of each as much as possible. So in this first one, I factored out a 7 from each term. So I pulled the 7 to the front. Here I pulled 35 to the front. So in the parentheses of the first one, I'm left with y squared plus 3y plus 2. Second parentheses, or the first denominator, leaves me with y plus 1 in the parentheses. Then here, y squared minus 4, that's the difference of squares. So that gives me y plus 2, y minus 2. There was nothing I can do with this numerator, so I left it as y minus 2. All right, so this trinomial can be factored. It factors out to y plus 2 times y plus 1. Once you factor it out completely, you can go ahead and cancel out what's in common with the top and bottom. I also broke down this 35 into 5 times 7. So we see that my 7s can cancel out. Y plus 2 cancels. Y plus 1 will cancel. And y minus 2 will cancel. So don't forget, if everything cancels out, then 1 is left. So in this numerator, everything canceled. And then in the denominator, 5 was left. Do sky blue. And so you're left with 1 over 5. All right, questions? Any questions?
Quick question. We got that other 1 because we subtracted the y minus 1. I mean, y plus 1 minus the y minus 2, right? On the top.
All right, so what do you ask, Eva? This right here?
Yeah, we got that because we subtracted the y plus 1 minus the y minus 2, right?
Well, we got that 1 because everything in the numerator canceled out.
Okay, so we of course we can't use the 0, so we use okay, all right.
Mm-hmm. Yep. And so we couldn't do it down here because everything canceled out except for 5, so there was still a 5 left.
Okay. I'm getting the hang of it. Gotta write real neat, and I write real sloppy.
All right. One last thing for today. Same section though, still 7.2. Are we looking at division? Division is the same thought process, just that it adds 1 step. And remember, that's when we flip our fraction. So remember, if we have 2/3 divided by 9/4, we change the multiplication and then flip the fraction that follows that division sign. And then follow the same multiplication rules. All right. So let's see how that works. If I have s minus s over 7 divided by s cubed plus 6s squared minus 7s over s squared minus 49. First thing I would do is go ahead and flip that fraction and change that to multiplication. So notice we go from division to multiplication, and I flip this fraction.
This is so scary.
You're not going over a roller coaster. I'm not making you get on a roller coaster.
Man.
All right. So now once you've done that, we do what we just did in the previous problems, because now it's multiplication. Remember, so that's what we just finished doing. You factor out each as much as possible. There's nothing to factor here, so you just leave that the same. S squared minus 49 is S plus 7, S minus 7. Here I factored out S. That's what we have right here. Let me erase some of this stuff. And then we look at this trinomial right here. S squared plus 6S minus 7 will factor out to give us X plus 7, S minus 1. All right, so now we can cancel out. Once you factor completely, next move is to cancel out what you have in common with the top and bottom. So S's can cancel. S plus 7 and then S minus 7. So everything in the numerator canceled, and it leaves you with 1. On the bottom, it's S minus 7. I mean S minus 1, excuse me. Questions? Any questions? All right. Here we have another one. 6m squared minus 54m divided by m squared minus 9m over m squared minus 10m plus 9. So just recognize this as a fraction by writing it over 1. Divide, change the multiplication, and then flip the fraction that follows the divisional sign. All right. Now we want to factor out each one. So I factored out 6m from each term here. That left me with m minus n in the parentheses. This was a resulting factorization of the trinomial, m minus 1 times m minus n. And then here, factor out m from each term. That leaves you with m minus 9 in the denominator. Questions? Any questions? Now we can cancel out what's in common. M's cancel. M minus n cancel. I said m minus n. M minus 9 cancel. And that's it. So it's
I have
only,
a question.
yep,
Would
I'm
you
listening.
cancel from the top or the bottom?
You said, would you cancel from the top or the bottom?
Mm-hmm.
It's only, you have to cancel out what's in common with the top and the bottom.
Top, okay.
Yep. So if m minus n wasn't down, I keep saying m minus n. If m minus 9 wasn't in the top and bottom, they can't cancel.
Got it. Okay.
Yeah. All right. So there's a 1 left in the denominator because everything in the denominator canceled. So that just leaves us with 6 times n minus 1 times n minus 9. All right. Then we got like one more questions on it before we go to the next one.
Now, this is something that, like you said, you got to do over and over again. It's more about repetition because it's steps.
Yep. I completely agree. It's all about putting that time in.
Yeah, you got to really sit down and do this to know what you're doing.
Mm-hmm. All right. So I think it's the last one. Yeah, it's the last one. So here, 5y minus y squared over y cubed minus 125 divided by y over y squared plus 5y plus 25. Once again, the first move to make, change your division to multiplication, and then flip the fraction. Whenever you're dealing with division, that's the first thing you're going to do. Then you try to factor out as much as possible. All right, so in the first one, I just factored out y. So that leaves me with 5 minus y in the parentheses. Now this next one, we want to be careful. This denominator is a difference of cubes. We talked about that last class when you have your formula. So y cubed is y cubed, but 125 is 5 cubed. So we were able to put it in this formula right here in the purple. In which the result is y minus 5 times y squared plus 5y plus 25.
Hold it. 2 seconds.
Yep.
Wow. Okay.
All right. So now we're going to look at what's in common. So this y can cancel out with this y here. I'll use this whole quantity of y squared plus 5y plus 25 will cancel out with this y. And it should be a square. I left out the square here. Y squared plus 5y plus 25. And canceling that out brings me here. Everybody okay before we look to finish it off?
No, I'm not. I got lost in my notes. Wait a minute, I'm trying to see. Uh, okay, and then okay, you can go ahead. I'm just writing there.
All right. So we recognize that we have similar expressions here, but not exactly the same thing. That's 5 minus y and y over y minus 5. If I were to rearrange my terms and put y, in 5, you have a negative y plus 5 and y minus 5. And so I recognize that I have opposite signs in each case. I have negative y and positive y here, positive 5 and negative 5 here. Whenever that is the case, if I factor out a negative, that would leave me with that y minus 5 in the numerator. And now I can cancel out y minus 5, and that is equal to negative 1. So if ever you see that you have opposite signs in each case, you can always recognize that it's going to reduce down to negative 1, even if you don't walk out the whole process. If you have opposite signs in each case, so I have a negative y plus 5, positive y minus 5. Each one of those signs are opposite, and that means the result will be negative 1. All right. Questions on anything I've said? All right. So, as always, make sure you guys try the stuff out. If you sent me an email within the last day or so, I'm gonna get caught up on emails this evening. So, just give me a chance. Just got for some reason, I just got a whole bunch of emails thrown at me this week. Last day or so, within the last day or so, no. So I'll get caught up, this evening. But once again, try the stuff out. See if you have any problems, you have any questions. Always feel free to bring them to class, or shoot me an email. We'll go from there. So you guys take care. Have a good one. I know somebody asked me, could they ask me something in the class?
Yeah.
So I'll stay on for her.
Thank you.
And
Take it easy.
thank you. You have a good one.
All right.